Okay, we're going to kind of start with an example, and then after we kind of go with the example, then we're going to go back and put our title in, so make sure your top line is blank, because we're not ready to put anything in yet. So I'm going to add some graph paper here, and basically what I want to do is graph two equations. But I'm going to graph them on the same set of axes. I'll graph them in different colors. So let's do y equals 2x minus 4. Y equals 2x plus 1. Since they are both written in slope-intercept form, I'm going to go ahead and graph them using the slope and the y-intercept. So let's get some numbers in here. I've got my arrow caps. Oops, go back. I've labeled my axes. Putting in these tick marks. I'm labeling every other number. Okay, so I'm going to graph the first equation in green. So let's see, it says go to where y equals negative 4, and then rise up 2, and to the right 1. So I'm at the point 1, negative 2, and then I'm going to draw a line through those points. Second one, I'm going to label blue, go to where y equals positive 1, then I rise up 2 and run to the right 1. So it should take me to the point 1, 3. And, they're parallel. What does that mean, parallel? What do you guys know about parallel lines? Morgan?
They don't cross.
Okay, so let's put some highlights. Parallel lines never, and I'm going to use a little bit more mathematical term instead of cross. I'm going to use the word intersect. So parallel lines, they never intersect. What do you think, Michael? Yeah, well, lines go on forever. That doesn't make them particularly parallel, so we won't add that bit. Anything else that you guys notice about parallel lines? Okay, Morgan?
Straight?
Yeah, lines are straight for all intents and purposes. Okay, Brandon?
Face each other.
Okay, yeah, it's kind of like, think about goalposts. You've got a right goalpost and a left goalpost, and that's what parallel lines kind of are like, except there's no connector bar between them. So they're always going to kind of run alongside each other, and think about our road system. We've got parallel lines for traffic, right? We've got southbound and northbound traffic, and they're parallel lines. We want them to be parallel because if they intersected, what's going to happen with the people? Yeah, there'll probably be some crashes going on. Michael?
They're diagonal?
Okay. These two particularly are, okay, because of what we were told to graph. Now, take a moment and look at the two equations that I graphed, and is there something there that might indicate that our lines would be parallel? Joey, what do you see?
The slopes are the same.
Ah, that is probably the most important piece, is this right here. So they have the same slope. So anytime I see two equations and I can identify the slope because it's written in a form that identifies the slope, which means it could be written in point slope form or it could be written in slope-intercept form. Standard form's not going to cut it for me. And I notice that their slopes are the same. What's going to happen every single time is my lines are going to be parallel. So that is actually the title of our notes, is we're in lesson 4.4, and we're just talking about parallel lines. Okay. Now, today's date, by the way, is the 26th. So basically, what I'm going to do is to give you, knowing that when I have two lines that are parallel, their slopes have to be the same. That piece of information is now going to show up when you're being asked to write equations. So let's do an example like this. Is everybody good with this? May I move on? Yeah? Okay. So I'm going to go back to plain paper. So let's do an example of how you might see this. Directions are going to say write an equation. In slope-intercept form. And by the way, don't drop the E off. It gets really annoying to see slop when you're slope-intercept form. Don't do that. Let's see. Write an equation in slope-intercept form for the line that passes through -3, 5, and here comes to keep it, and is parallel to the graph of y equals 2x minus 4. Okay. So in order to write our equation, we need two pieces of information. What are the two pieces of information we need in general to write any equation? Liam?
Slope and Y-intercept.
We need slope or y-intercept, but y-intercept is very particular. That'd be great if we had that. In general, what must we have? We have to have, we could have the y-intercept. What must we have, Morgan? We need a point of some sort. So we need a slope, we need a point. They gave us a point, and what they told us is that our line is parallel to this line. So that means what we're going to do is grab out the slope from the second line and use it for our slope. So that's going to be step one, is to identify the slope from given line to use as slope in our line. Now, this one was super nice that they wrote it for us in slope-intercept form. So finding slope is pretty simple. Y equals 2x minus 4. So for us, we can identify the slope as being 2. So now we're going to use that slope with the point, and in this particular case, we're going to use point slope form because that's the information we have. Okay, so point slope form says y minus the y coordinate of 5, because that's our given point, equals the slope, which we just identified to be 2, times the quantity of x minus the x coordinate from the point of -3. Now, I have a little contender. Notice inside the parentheses I have double negative, so I'm going to make it a big old plus. But that's not the form they wanted. So what am I going to do at this point? Okay, yeah, so we're just going to generically say solve into slope-intercept form. So Michael's absolutely right. The first thing I'm going to end up doing is distributing. 2 times x is 2x. 2 times positive 3 is positive 6. And then to get y completely alone, I'm going to add 5 to both sides. And we get y equals 2x plus 11. So something else to think about. We talked about what was the same between the two lines that we had graphed, and now we've got another example of two lines that have the same slope. What's different about parallel lines?
Oh, the sign of
Patrick?
X coordinate.
No, the x is, in front of the x is 2, and in front of the x is 2. So our slope is 2. So x value, then in front of the x value, that doesn't change. What is different, Brandon?
Y.
Okay. If you notice, the y-intercept is different. In the equation ours was parallel to the graph of, it said the y-intercept was -4. In the equation for our line, it was +11. So let's go back to over here, and let's add that little comment under parallel lines. They have different y-intercepts. And you can see in our graph, the y-intercepts are different because you've got one at -4 and then one at +1. Okay? So that's always going to be true. They'll have the same slope, but they'll have different y-intercepts. If they had same slope and same y-intercept, then we're talking about the same line. Okay? So, now, what if they took our equation, but instead of asking us to put it into slope-intercept form, what if they said standard form? So let's do one more, and let's add a little ugly. And what do I usually mean when I say let's add a little ugly? Yeah, let's add a fraction in there. So we're going to write an equation. In standard form. For the line passing through point 4, -1, and is parallel to (2x minus 3y equals 5). Okay, so we're going to do the same exact process we did before. We need to identify the slope from the equation they gave us that our line is parallel to, but the issue becomes it's not readily identifiable. How do we do that? So what are we going to do to identify the slope when they don't outright tell us what the slope is? What's the process? So we're going to take this guy and we're going to put him into a form that identifies slope. So the easiest is slope-intercept form. So we're going to change to slope-intercept form. So I abbreviate slope-intercept form as S-I. So to do that, we're going to get y alone. We're going to subtract 2x from both sides. We get -3y equals -2x plus 5, and then we divide everything by -3. Now again, our focus really is not here. We don't really care about the y-intercept at all, so I can ignore him. What I want is what's in front of the x. 2 negatives make a positive, so I get 2/3 x. So this is going to be the slope that we're going to use. Okay. So now we're going to go, again, what I have left is a point and a slope. So I'm going to go ahead and do point slope form. So I have y minus the y value, which was the -1, equals the slope we just figured out was 2/3 times x minus the x coordinate 4. So small adjustment is changing the double negative to a positive. And then this is where we're going to be smart about this. What do we need to make sure doesn't exist in my standard form? Fractions. So how am I going to get rid of fractions? So we're going to change the standard form. And we're going to multiply everything, every product, every term by 3. Now when I say term, that 2/3 times the quantity x minus 4 is considered a term at this point because of the parentheses. So this leads me to 3y plus 3 equals, 3's cancel on this side, 2 times the quantity x minus 4. And then we just keep solving. So we're going to distribute to get rid of the parentheses, because otherwise we're stuck and can't do anything more. 2 times x is 2x. 2 times negative 4 is negative 8. Next, we need to get the x's and y's together, preferably on the left, but I'm going to show you, again, slightly different option. Some kids like to take the y to the side where the x is positive instead of always taking the x to the left. So I'm going to just show you another alternative way. Since my x is currently positive on the right side, I'm going to subtract 3y from both sides to get the x and y together. At the same time, I need to get the constant to go on the other side. So I'm going to add 8 to both sides. So what I have at this juncture is 11 equals 2x minus 3y. But that's not quite standard form. We just need to use that symmetric property, and our final answer would be 2x minus 3y equals 11. Now, look at this answer and compare it to the original equation. Do you see something interesting? What do you guys see?
11 and 5.
That's not interesting. 2x minus 3y? 2x minus 3y. So in standard form, you will see similarities. The not as interesting was the 5 and the 11, right? Because those two numbers are going to pretty much play the role of a y-intercept of some sort. It's not the exact y-intercept, but that's what that constant ends up becoming, is going to be a y-intercept. So it makes sense that they should be different because we know that to be true with parallel lines. Okay? All right, that's it. Now you guys can be working on your homework.